salute of the EDOCOM attitude. All systems are nominal. Odyssey is go for EDOCOM support.
Great to hear from you. Thank you very much.
We have a cruise stage shut about to happen.
For all of EDL, so we will have their coverage. Things are looking good for them, and they're looking good for us. We're about 1 minute to cruise stage separation.
We're seeing the transition to tones now. The system should be configured shortly. And we're seeing carrier only.
The Eagle's changing to tones at this time. So we're switching from telemetry. We've lost telemetry, and we're going to move to just tones.
EDA acquisition. And we're seeing heartbeats.
We are receiving heartbeat tones this time.
Affirmative, we're seeing the expected 2 seconds of heartbeat, followed by the 10-second carrier pulse.
Now we can see something that could be consistent with cruise stage separation in the Doppler.
And showing a good strong signal, higher than expected carrier power. And continue to see heartbeats. EDOCOM tones look good.
We are receiving heartbeat tones at this time. Things are looking good. We see that we are priming the entry RCS thrusters. Cruise stage separation. In about 1 minute, Curiosity's EDL software will wake up and begin final preparations for entry. The first action it'll take is to fire some warm-up pulses to get the entry RCS thrusters going. The pulses will ensure the spacecraft will get the thrust that we want when it's counting on it.
We did see the heartbeat signal drop low for a second as the signal passed by the donut of the cruise stage.
Seeing RCS warm up.
Flight, this is enough.
Yeah, flight, go ahead.
Could you check with the AIS whether we should be seeing one-way data on the station?
Hey, copy.
Curiosity is reporting that it is spinning down and turning to entry.
Flight HS, we've been one way for a while now. Roger that. But currently we're just seeing the tones, obviously. Roger.
Vehicle's reporting that it has completed its turn to entry and spin down, and has separated the cruise balance mass devices. At this time, the vehicle's just sending heartbeat tones, just as we expect. It should be quiet for the next several minutes, hopefully. We are about 7 minutes to entry. At this time, Mars is actually pulling Curiosity in, and we're speeding up. We should be traveling around 5.4 kilometers per second on our way to about 5.9.
So, Rob, what are your thoughts at this point?
Well, I'm very
Variation
excited.
in the pattern, antenna pattern is
This is
reflected
the
in variation.
this is the part that really is entry. This is where we're going to get to the top of the atmosphere. The great thing is that the propulsion system's shown to be working. We're turning the vehicle. It looks like the vehicle is going to be doing its entry job very well. I'm very excited about that. Everything is going very well.
Right.
So make sure everyone keeps their eyes on the television because we might actually get some pictures if all goes well. And we might be murky and covered with dust when we first land. But we might get some pictures today.
Wow. At landing.
Just a few minutes after landing.
Excellent. Okay, we're standing by.
Thank you.
We're just under 6 minutes to entry. We're continuing to wait for entry interface. The spacecraft is continuing to send heartbeat tones, telling us that everything is okay and there's nothing significant to report. This is as expected. It should be quiet for a little while, at least. We're now 5 minutes to entry. Continuing to receive heartbeat tones. Everything is good. At this time, Curiosity should be up to about 5.5 kilometers per second.
So what's taking place now?
So right now the vehicle is flying through space. It's actually in deep space still. In fact, not until after we hit the entry point will we actually begin to feel the force of the atmosphere gradually building on that heat shield. So really it's still a spacecraft. It hasn't actually become an aircraft. But we've checked out its rockets. It's actually used to turn the vehicle. It's turned to the right attitude. And that means it's ready to go. And as soon as we start feeling the atmosphere, it'll start doing its role to get to the turn as part of the guidance that it does. It starts off with a right bank, and eventually will make a left bank, and then make another right bank as it makes its way to the landing site.
So it's a capsule right now.
It's a
headed
capsule.
in.
It's just a bare capsule. Nothing looking out. Just the radios is the only thing that's sticking out, and that's what we're getting. We're getting tones from that vehicle right this second.
Okay.
Now we're not getting Odyssey data yet. That doesn't happen until a little while later.
After parachute.
Actually, just after entry, just before parachute opens up.
Okay.
EDL phase dynamics.
Did that work out?
Go ahead, Dynamics.
Just FYI, OD227 runout looks like missed distance of 232 meters. Over.
232 meters.
That's correct. Less than the divert.
Roger. We can expect a brief signal dropout when we switch to the TLJ.
We're at 3 minutes to entry. At this time, MRO should begin picking us up. But remember, we won't get that data for a while. It's got to store it and then send it back down here for us to decode. We're still seeing heartbeat tones. Everything looks good. Spacecraft should be up to 5.6 kilometers per second.
DDL team is reporting that the latest runouts, which is using the latest nav, our best guess of where we are, show us that the best guess of our landing target location is about 232 meters from the landing target. So, looking good so far. We're continuing to receive heartbeat tones. Everything looks good.
OD227 or OD228?
That is OD227.
Thank you. You guys have now OD228 in your possession?
There will be no 228 for us, phase.
That's just fine because the difference
1
is
minute to entry.
within spitting distance.
Affirmative.
The vehicle will switch antenna shortly. We'll have a short dropout when that occurs in the tones, switching to a tilted antenna that will be used through entry.
There's 30 seconds to entry.
As we come up on entry, we'll expect a 2 to 3 second outage in the XNet signal as we switch from the PLGA to the TLGA.
We're switching to TLJ, signals dropped, and it's
We just saw the signal drop that in case we change antennas.
We're seeing heartbeat tones again after the switch. Things are looking good. Got tones back again. Coming up on entry. Vehicle reports entry interface. At this time, it'll begin pressurizing the propulsion system to increase the thrust of the system. It'll use that for all the maneuvering in the atmosphere we're about to do. Back to heartbeat tones. We're standing by for guided start of guided entry.
Nav can see the entry in the atmosphere in the Doppler.
We are beginning to feel the atmosphere as we go in here. The vehicle has just reported via tones that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. It is starting its first bank reversal. First bank reversal complete. We have seen peak deceleration. We've passed through peak heating and peak deceleration. It is reporting that we are seeing Gs on the order of 11 to 12 Earth Gs.
Flight GDSA.
GDSA flight go.
We are processing data from Odyssey.
Bank reversal 2 is starting. We are now getting telemetry from Odyssey. Bank reversal 2 complete.
Copy, bank reversal 2 complete.
Thanks.
Standby flight. We have a connection, but we actually do not have any data yet.
Copy.
We can expect some intermittent contact at this time as the signal gets
There we go.
increases to
Bank reversal
respectable
3
levels.
starting. We are now seeing
And we
telemetry
have
from
our
Odyssey.
CDP.
Okay, copy.
And visualization is updated.
We have entered heading alignment.
Very good.
At this time, Curiosity is no longer trying to control how far it's flying downrange and is just heading directly for the target.
End of range control, air use minus 1.2 kilometers.
Minus 1.2.
1.2.
1.2 kilometers.
Minus 1.2.
1.2.
The EL team is reporting that that things look pretty good at the end of range control. We have converged a lot of the error, and we should be heading for the target.
Flight EDL, PDS warning is okay.
Copy.
Power on.
We are seeing a tone from
The 1 gigahertz.
indicating that we have seen heating on the heat shield through the MEMD instrument. Everything looks fine. at an altitude of 17 kilometers or so. Vehicle's reporting heartbeat tones again, indicating that everything is fine during heading alignments. We are standing by for straighten up and flight right and parachute deploy. Vehicle's continuing to decelerate. We're down to about Mach 2. As a reminder, we should have parachute deploy around Mach 1.7. We're at 15 kilometers altitude.
We've begun entry balance mass jettison. Predicted mid
Stand by for parachute deploy.
downrange is 1.597 kilometers.
EDL ops, Odyssey Systems on EDL ops.
Parachute deploy. Thrusters have been re-enabled. We will control our attitude on shoot. We are decelerating.
Ritz mode under
Our 10 kilometers decelerating and descending. We are at 150 meters per second.
Dynamics phase. Come back again with wrist mode dynamics.
Ritz mode is nominal.
We are at 9 kilometers and descending.
Valid range.
That filter converged with a velocity correction of 0.7 meters a second. We've acquired the ground with the radar. An altitude of 8 kilometers. Heat shield has separated. We've found the ground.
Expand tones due to earth occultation as expected.
We're standing by to prime the MLE engines in preparation for powered flight. We're down to 90 meters per second at an altitude of 6.5 kilometers descending. Flight EDL, we got some tweeter warnings. It is in battle short mode, so I should power through. Director of Communications at this time. You may have lost it already. We're down to 86 meters per second at an altitude of 4 kilometers and descending. We've lost tones from Earth at this time. This is expected. We're continuing on Odyssey telemetry.
Ground solution equals minus 10.8 meters. Vertical velocity of minus 80.
We are priming tower semi start enabled, standing by for batch cell separation.
Signal to Odyssey is still strong.
We are in powered flight. We're at altitude of 1 kilometer descending, about 70 meters per second.
Signal to Odyssey remains
Down to 50 meters per second. 500 meters in altitude. Standing by for Skycrane.
Constant velocity accordion nominal. Altitude error 5.9 meters.
We found a nice flat place. We're coming in ready for Skycrane. Down to 10 meters per second. 40 meters altitude. Skycrane has started. Descending at about 0.75 meters per second as expected. Expecting bridle cut shortly.
Signal to Odyssey remains strong.
Tango Delta nominal.
Yep. EDL comm configured.
Review stable.
UHF telemetry.
Review stable.
UHF is good.
Touchdown confirmed. We're safe on Mars. Time to see where our curiosity will take us. received telemetry from Curiosity. We're safe.
From the surface of Mars.
ASCAM sequence is kicked off, waiting for images.
Heads up, folks. EL ops, signal to Odyssey remains strong.
Flight EDL images are starting to come down. We're beginning to get
Alright, we
images
got
from
images
Odyssey.
coming down, folks.
Visual comm configure standby for images. Rear has
Big
cam
thumbnails coming down.
Odyssey data is still strong.
Odyssey data is very strong.
Odyssey's nice and high in the sky. At this time, we're standing by for images.
Thumbnails are complete.
Got thumbnails.
Polling is complete.
It's the wheel. It's the wheel.
There we go. We can see a wheel image. We are wheels down on Mars.
Oh my God. We'll do a proper hug on the other side.
Keep watching, guys. Keep watching the stream. There's more stuff. Any minute now. No. 2:56.
Okay, okay. So here we are. We're going to start. Go ahead.
Okay.
So we have landed at the time we thought we would, and we now have our first image.
We have our first image. This we've got is a 64 by 64 thumbnail. The front, a rear has-cam image. You can see the shadow there. I'm not sure exactly which our orientation is of the vehicle, but we're looking through it. I think in just a few minutes we might get even a larger 250 to 256 frame pixel image of that same end. So we're looking at the shadow. See, the horizon is actually in the distance. You can't really tell that. So we're looking actually at the shadow of this late afternoon sun.
So these are the rear has cams,
The rear has cams.
and it does have a dust cover on it.
It does have a dust cover, but it's the dust that covers the problem. It's the fact there's dust in the air because we have just blown dust all over the place with our descent engines.
Fantastic. So there could be more.
There could be more. If we wait, we might get. Oh yeah! This is the high res. This is the 256 by 256 image. This is the higher res. You're seeing dust particles on the window. You can see the horizon there in the background, and there is the wheel of the rover safely on the surface of Mars. I can't believe it. This is unbelievable. We might get another one of these, and if we're lucky, before Odyssey goes away, we'll get 2 more of these same images going the other side of the vehicle, and also probably dusty. This is amazing.
So that is one of Curiosity's rover wheels
Exactly.
on the surface of Mars.
Yes. Oh wow! Now we have another image coming down. This is a view looking the other direction. It's still being processed. You'll see it in just a second here. This is another thumbnail image.
Is that a shadow?
That's the shadow
Of the rover.
Curiosity rover on the surface of Mars.